So now actually that's the data I just mentioned. So let's say we have 4 populations. We collect the data, and in Excel you can, of course, first we wanted to know the sample size for each population. So there's a function in Excel called count. So it's just like a let's say I remove this. So the sample says you just do equal, and then you just type CO actually will. Of course, you need to have a rough idea, what function you are going to use, So well, yeah, English is your mother language. Actually, that's easier for you, compare with the Chinese students. So the count, and then you just select those data, and it will tell us how many data points here. And then in Excel, actually, once you have one formula, you can drag it down, up here. So when you drag, so these cells also move directly. So immediately, we have the sample size for parent B and F1. But if we check F2, because we have more cells, so in Excel, it just, if you point this is the input area, you will see, the area of cells selected. So you just change that, so you have the sample size. So basically, there is another easy way. If you just select the area of data, as you can see, it immediately tell you some data here. This is sample size. This is our summation, basically. So this is the average. So it's as simple as that. So the mean, I wanted to find the population mean. Mean here in Excel function name is not a mean, it's an average. You select the average, and then you choose the data, the area of the data, and enter. And you drag it down. Here again, in Excel actually you can check whether the correct area of data is selected. So here you can change, the cells of data, and then immediately you have the mean. So the variance, can you follow me? So the variance, the function called the VAR. So the VAR, as you can see here, it gives 2. So before, I think this Excel 2007, you should also have 2. So that's VAR.P and VAR.S. You know the difference? So the difference is, it's the sum square divided by n, or n minus 1. So the sample here, which S here actually means a sample variance. The P here, which means the population variance. So the difference is you know how the variance is calculated. Of course, first we need to calculate the mean, and this is for each data point. So this we call the deviation, or it's the deviation for each data point. we give a square, and we give a sum. So we call this sum square. We will use this many times. It's the sum square. So the VARP is the sum square because the total of n samples is divided by n. So if the sample is the sample variance is the same machine, it's divided by n minus 1. There's a special name for n minus 1. The n is the sample size. There's a special name for the n minus 1, which is degree of freedom. Okay, so in ANOVA, we will touch degree of freedom, quite often. We need to, many times we need to know the degree of freedom. So this is the degree of freedom. So you know the difference between the two. Then actually the two values can be used to estimate the population variance. This again is another estimate. So this is the population variance. Actually have two estimates. Can be estimated by this one or by this one. So this one, which one is better? Guess. So this one in statistics we call it is unbiased. Unbiased, which means that if we have the calculate the expectation is equal to. So this one is actually approximately unbiased. So this actually is also estimate we call the MLE. It's maximum likelihood estimation. So this is unbiased. So most time, which one we use for, if we have the sample. So most of the time we use the sample variance, so VARS, and then we select the data, and we enter. We will have the variance for first the population, and the second one, and the fourth one. Again, the fourth one we need to select the whole observed data. Okay, and then the minimum. So the function is you can you can do that. It's just MIN is the name of the function, and the maximum is max. Another tool is about is called the skewness and the curves. Skewness and the curves. So basically, it's measure the deviation from the normal distribution. So you can also, so this function is called the skew, and the last one called the cut. So this may be not a very convenient, one by one. In Excel, actually, there's another data analysis which can give all this values. They are called descriptive statistics. So it's some basic parameter estimate about a number of data. Let's see. I think I see data. Okay. We will show you. I think you can follow me. Hopefully, it's there. You can go to File. You can go to Option. You can go to Add In. You can select Go To, and then you select the Analysis tool. I think it's yeah. Can you find it here in your computer? So I just want to see, this button there. In your Excel, you go to File, Option, the second last, and in this interface, you click Add In, and in the end, you click Go To, and then you see this interface, and then you click Analysis tool. You click OK. And then you see the data analysis in your interface. Okay. 1 second. File. Option. Add in. Go to. Yeah, data analysis tools or whatever. And it's the second one. I don't know the English name. Data analysis tool. Yeah. Okay. You got it. And then, you will see the data analysis. So the data analysis, that actually there, as I said, there are a lot of other functions we are going to use. Now, if we click here, you can see you can do some ANOVA, you can also some correlation or whatever. So today I want to only use the descriptive statistics. It's the third one. So in your data, you click data analysis. And here you click the third, no, it's the fourth. The fourth one. And descriptive statistics. You click OK. Yes. And then let's say we just select the first 10 data. And you can output, anywhere in this sheet, or you can output in a new sheet. It's okay. So I will output in the same sheet, maybe just starting here. So what do you have?
After output then
No, you first you select. Let's say we want to, this one it want the data in one row. So just select the first three populations, and then you can select. We do the analysis. For each by row or by column. Of course, we want to find it by row. So you need to make sure you click by row, not by column. By column, so it will give us the descriptive study for only the three. So now we want for for the 10 rows. So that's the difference, by row and so and there are some place you can click. Let's say we leave this one, and we want output, in the. So here you just put a starting cell. It must be empty because the output will overlap any other cells. So it's better there are enough area to have all the outputs. The output is not just the one. So I click here, then the output will be followed here and up down. So here you click, we want to have the descriptive, the descriptive or the summary statistics. Anyway, so of course, if you want to output to a new Excel sheet, you just select here. So if you, I will skip other, then you click OK. So it's all the you can check give the mean population mean. So this is not a variance, it's the standard deviation. If you make a square, that's the variance. It gives us more. Actually, this is the method. This is the mode. This is the standard deviation, variance, skewness, cutters, and the sample set. Sample set is where it's named and select and so maybe I didn't select all the data. I'll do that again. Yeah. So maybe this should be degree of freedom. I think before I made a mistake, I shouldn't click here. So if I click here, it means some, some title. So that's why for the data sample set, I see 9, I don't see 10. So please don't click here. So now, so the sample set is 10, 10, 10. So this should be exactly same as we calculate here. Can you see this? Can you have this results? So you need to make sure somewhere you have to click somewhere you must not. So here, of course, if I select, I can select actually the title. If I select the title, then here I must click here. So because so the data you can select the title here, or if you select the title, you must check here. Okay. If you only select the data, so you must not check here. So of course in SAS SPSS you can have this, you need to write a command of a line. But you also need to, I'm not sure, I also need to specify which one you want or not. I'm not sure which one is more convenient, I still think if you know how to do this in Excel, okay, you got it? Everyone got it? Okay, so if you have some data, first consider Excel. If Excel you don't, not enough, you use some.
Problem because if you have some missing data, so the Excel don't give you the result.
I think you can have, let's say we have put the missing data as a star. So it can immediately, as you can see here, if I put a star, this number it immediately become none. And everything changed, simultaneously.
Well, I just like tried my previous data. There are some data is missing, so I put it star over there. It's not integrated.
Where? Excel?
Yeah.
Let me see. Let me check now if I can use the describe. Okay, so it seems this one doesn't work. But each function works. Yeah, maybe it's not as that not that smart. But here, yeah, if you leave as blank, it still works. For the each function here.
Because here we use formula.
Mm-hmm.
So that's they automatically change that.
Yeah, yeah. So it's automatically changed. So if you use the SAS, you need to run the command again. Okay, be quiet. Now we talk about another one which is very useful. Also you don't need to use the SAS to draw the frequency distribution. Let's say we have hundreds of data. We want to make some groups. That can be easily done in Excel. Let's say we wanted to draw the distribution for the F2 population. So because of the the first three we just use the 30 data point as an example. So of course from here I know the minimum how to make a group. So the minimum value is 80, maximum is 100, about 170. So I make the group from 80 to 170, and the group the group is 10 centimeter if you want. Okay. So I made this. I'll remove this. So I made the group, and then of course I can find the mid group value. Mid group value for here actually it's the average. It's 85. And here is 85. Here is 95. Is the middle. So that's the mid group value. Mm-hmm. Sometimes it can be added up, automatically. I'm not sure. Anyway, just use the first one plus the group says 10. Of course, if you want, we can also draw the frequency distribution for the two parents and the first and the F1 hybrid. Now I want only draw the distribution of F2. So here, the distribution frequency actually every group have a frequency. So first, I need to select all the cells. So I made this how many group? Maybe 10 group. So I select the 10 cells because we will have 10 frequencies. And here you in the input area you click equal, and there's a function called the frequency. You see the frequency is there. So the frequency actually there are three things I actually two input. So first I select where is our data, and the second we select how we make the groups. So the first one we select the 30 data. You just select. Of course, you can also enter. I select by mouse, and then you give a comma, and then I select these are our groups. This is how we group the 30 data. And now there's a trick here. You need to click 3 buttons at the same time to see the result. So the 3 button is Control, Shift, Enter. Control, Shift, Enter. Don't release. You press Control, don't release. Then press Shift, don't release, and then last press Enter. So the 3 buttons together will give us the frequencies. So I think many times when we collect data, first thing we need to make a frequency distribution. Okay, and now I want to draw a bar graph. And you never make any graph in Excel? Well, I don't know what do you do by Excel? So the Excel is
because the highest value is 170.
so it's the middle actually it's the middle group from 80 to from 80 to 9. Of course, this one actually you don't use. So it represents the from this point to from this point. So this one represents from this one to this one. So it's so this is one data minus. Okay, we draw a bar graph. Actually, I'm going to retire in a few years. I have, I think, more or less 50 journal articles. Almost all our figures in the articles, I draw in Excel. I have some professional Sigma plot, but it's Excel. It's good enough. Okay, so draw the bar graph. You select the frequencies. You go to, I think you go to insert. There are a lot of graph. Even you can draw some contour graph here. Let's say we select the simple one is the bar graph. You select your data, immediately you have a distribution. And on this graph, you can easily change, the X, anywhere you right click, we can change the X, because the X is okay, the X is not what we want. We want to draw the middle group value. So select the data. So anywhere you right click, so allow you to edit your figure. You can add something, you can remove something. Actually, there are more. You can change the title. And there are a lot of the template you can use. You can also easily change the bar graph to a line. I can't not find how to actually the X should have a title as well. It should be easy. Anyway, so in this figure, actually you can edit the title, you can edit the X or Y, and then this figure actually you can copy paste to anywhere. You can copy paste it to your Word, and it's have a good resolution. Okay. Anyway, as I said, we want to draw some distributions. So let's say these are the mean and the variance estimated from the three populations, and this one is F2 is a mixture distribution. Of course, the frequency is a 1-to-1 frequency. So the value from before is about from 80 to 180. So these are the possible value of X. In other area the probability is almost zero. So I don't consider that. So these are the three populations and the density function. Also use that. So the density function is normal density function. We use here is There are a lot of distribution. F distribution is just the F square distribution. Almost all statistical distribution is there. So here we use the normal distribution. And first we select the X. And the mean of the distribution, I just give the value is 160. So this function, they don't like the variance, it's like the standard deviation. The standard deviation is the square root of the variance. So I just input as square root. So here I use another function called the square root. Square root of 27. And the last one actually tell us we'll come back to this again the next class. Whether we want the probability density or the probability. Confused, no? So this is the normal distribution, okay? Let's say this is 160. So the variance is 27. So the density here actually tell us, of course, there's a function for this curve. You want to measure the function? It's a summation like that. Anyway, I remember this. I don't request that you remember this. This actually is the function of this curve. So here there are two possible values. So you can choose true or false. So the true means if this is the x, the true means the function will give us the area and this curve on the left side. So basically this is the probability. So if there we select select the true. So here I don't want the true. I want to see the density, whether the distribution is not accumulative. So if I select the false means it's just the head of this line. Now understand? No? Do you know? Because I want to draw this line. So I want to know where. For this x, what's the where value? Not the area, on the left of this line. But next week we need to also know the probability. So here that's where false, which means 0. So you can give either 0 or false. That's the same. So you put a 0 there, and then it gives us the density for this distribution. So basically this is the normal distribution for the distribution of this normal normal distribution, the curve of this one. Okay. So and then for the other two, you just drag down, drag. You just you need to move the x. And this one you need to change the mean value from 160 to 149, and the variance is the same. And then you make this one, you just change the mean to 103, and x is not here, x is here. And then we can have the distribution for the other two. So this actually represents the plant head in one population, in another one, and this is the F1 hybrid. So basically, that's three distribution. If the plant head is controlled by one gene, so those three distribution represent the three genotypes. One is big A, small a, and small a. Let's say this one is tall. So this one is represent the short genotype. So this one actually is the F1 hybrid. And so we make the cross between this parent and this parent. So this is the genotype of F1. So the F1 self will have F2. So based on genetics, what's the proportion of the three genotypes in F2? What's the proportion of the three genotypes in F2? Nobody knows.
One.
You don't know. Yeah, if you don't know, means you know nothing about the genetics. This actually is not the knowledge in university. It's a knowledge in high school. In the high school, if you learn biology, you should know this. Yeah, so the 1, 2, 1, or otherwise we have 1/4. This genotype, half of this genotype, another quarter of small a small. You forgot or you don't know that? Hopefully you forgot. But then, wow, that shouldn't forget. Forget. Okay, now actually the distribution of the two is a mixture. So here we call it a mixture because it's a mixture of three genotypes. And these are their frequency. So that's why in the end, I wanted to see how the F2 looks like. So basically, this one have a frequency of a quarter. Of course, you can do the multiply by a quarter, and you plus the second one is F1 hybrid. You multiply by 0.5, and the last one you multiply by a quarter. And then I drag it down. So this should be the F2 looks like in F2 we see a ratio. What ratio it is? It's 3:1. There are three with the tall because the F1 hybrid is more closer to the tall plant. So we can classify this the phenotype as two phenotypical groups. This one have 3, this one have 1. It's 3:1. So this gene is almost dominant. It's a dominant gene.